This presentation is just going to review pretty quickly the scientific method. I don't want you to listen to this for a long time, so I'm going to try to keep it as short as I can. A lot of the slides have the information that you need on it. I don't like reading slides to people, so I'm going to assume that most of these you can read for yourself. When we use the scientific method, you use it not only in science, we use it in almost every field, because this is how we find out new information. And thus we use that new information to either research more or to come up with a theory or a model that we use. So you always think science when you hear this, but you do use it in your everyday life. Now, it's a cycle. You start off with a question or observation, and then you go through the hypothesis, the experimental design. You collect data, and then if your conclusion was right or your hypothesis, you proved it, you're fine. You can say you accepted your hypothesis. But if it's wrong or it didn't meet your expectations, you start it over again. And this can go on and on and on. It's a continuous cycle until you get an answer or you get a theory. So to start with, you have a question. Something is missing. You've lost your directions. You need to figure out a cure for AIDS. In psychology, you need to determine why people kill others. Is there some gene that causes it? So you can see this goes on and on and on. So you need to come up with a very good question. It can't be vague. You need to know what you're really questioning. Also, as you develop this question, you may need to do a little background research. You need to understand what you're questioning. And if you don't have any background information, you're not going to be able to come up with a good question. So it's important that you research it, look on the web for it, or if it's something, say you lost your keys, what do you normally do when you lose your keys? Where is possible sites since the last time you saw your keys? All of those are questions that you might consider based on what your research is going to be. So we start with the hypothesis, and this usually is often difficult for students to define. And it has to be testable and specific. You can't go off and give vague data or vague questions. It needs to be a very specific and testable statement. It could be a statement, it could be in the form of a question. What I recommend for my students is to use the if-then method. And using this format really helps you put your variables into the right areas. Most of the time you're going to have a control group which doesn't get the experiment for you to compare your results to. And then you have the experimental group. So those are usually the two groups. The hypothesis is actually always called an educated guess. It is something that you are using to answer your question. So it is a possible answer to your question or an explanation. It could be, it is a prediction. So you could call it a prediction also. If you look at it that way, it's easier to develop your hypothesis. Here is an example of a hypothesis, and this is one for drug research. If patients are given drug X, then their tumor size will decrease by 10%. So right here, you know you have patients, you have a drug, and you expect the tumor size to decrease by a very specific amount. If it doesn't decrease, then your hypothesis is not true, and you have to start over again. Maybe it's the drug's fault, or who did you select to research? Usually you start off with mice and not people. People are really the end of the line for research because you need to have a lot of papers signed saying that you're not going to harm the person. So when you're testing a drug, it really takes a while to get to a point where you're going to be looking at humans. So you could say if mice are given drug X, usually you would have two groups of mice, one with a tumor, any kind of tumor, I'll leave it at that right now, and it's a very specific size. Say it's a couple centimeters big, and you expected to see it drop by 10%. So you have a group that are getting the drug, that's your experimental group, and you have a group that isn't getting the drug. That is your control group. And then in the end, you're going to set a specific amount of time, say 60 days of treatment, how often they get the drug. You need to control that you have the same type of tumors in all of the mice. So you may have to cause the tumors in the mice so that you have something to compare. You need to have a baseline that is comparable, because if you want to see results, you've got to make sure that everything was controlled. How they lived, what they ate, the amount of exercise they got, gender, age, all those things should be controlled for, and both groups should be the same. So if you're looking at variables other than the control group and the experimental group, there's something called the independent variable or the dependent variable. The dependent variable depends on the independent variable. So the independent variable is what you vary, and the dependent is what you measure. For the most part, in my classes, I really don't go into these too much, and I don't expect you to. And since you're listening to me, you are in one of my classes. So I just put this in so that you knew about these terms in case you read them later. But for the purposes of my classes, you don't need to identify these. So you need to practice writing hypotheses. So here is a scenario. A researcher would like to determine the effects of groundwater pollution on size of corn plants. They notice plants that are not exposed to water pollution tend to grow taller. See if you can come up with an answer to this. Try to put it together and we will go over it. After you get your hypothesis, you need to do your experiment. And we've already talked about the groupings when we talked about the mice. And you need to make sure you've got your protocol. That is how you're measuring, how you're keeping all the subjects same type, age, gender, living situation. And it's important you only change one variable, because if you start saying height and weight are going to change, well, what do you know is the result of what you're testing? Just do one of those. You don't want to do any more, because you just make your results a mess. After the experiment, now you have to look at the information you got. The information is your data, and for most parts in both of my classes, I don't expect you to develop the data. Usually it's done with math and graphs and tables, so you usually do not have to do this for my class. I usually stop at the hypothesis. Sometimes if you're doing a project, you may have to come up with the conclusions in the experiment, but you usually don't have any data other than one or two things that you have discovered. So now is the end. This is your conclusion. Did you answer the hypothesis? If not, you need to go back and reevaluate, restate the hypothesis, change what you're testing, or it supports exactly what you had said. And then you may need to do further research to get to a more specific conclusion. So here is a conclusion. Plants treated with fertilizer grow taller than those not treated with fertilizer. So these are the steps. They're documented almost everywhere. Any article I've given you, the statements you need to go through are, these are the steps, and this was the chart I showed you. It's usually in a chart format because it's cyclic. You go back. If your data doesn't prove your hypothesis, you need to go back and do more research, get more background information so that you can develop a new hypothesis. So, in conclusion, the hypothesis is something that you observed in the very beginning and you questioned it, or you lost your keys to the car. What are you going to do to find it? You are going to go through the steps of the scientific method. You may use them and not even realize that you're doing it. And the hypothesis is specific and testable. So it needs to be written in such a way that you have your variables that you're going to test. And the preferred way for a beginning student is to use, if I do this, then I will see this statement. The if-then statement as a hypothesis really does make it easier for the student to put the variables in the correct position without even knowing it.